Okay, in our last video, we used one equality to solve a pretty simple problem by creating conversion factors. And now we're going to do it again, but with a slightly more difficult problem. And so we're going to write some equalities here, more than one this time. So let's say that I tell you that one red square is equal to, let's say, 3 green circles. And remember that it's okay to write it like this. Originally, we were drawing out all the shapes, but right now what we're doing instead is writing a coefficient with a unit. The number, so we're writing the number of a certain thing. So 1 square, 3 circles. And if we wanted to, we could draw them out. We could draw 1 red square equals 3 green circles. We could draw it out, but it just gets really tedious to do that. And so it doesn't really save a whole lot of time in the end. So we're going to do it this easier way. And now I'm also going to tell you, oh, as usual, I always end up doing that. Hold on a second. Let me change my color here to black. So now I'm going to tell you that 1 green circle is equal to, let's say, 2 gold stars. Okay, and just for the sake of really pushing our knowledge and skills here, let's do one more conversion factor of 1 gold star is equal to, let's go wild here. We're going to do 5 blue hexagons. Okay, so these are equalities. Let's turn these into conversion factors. Okay, so for each of these, there are going to be 2 conversion factors that we can use to multiply something by 1, right? And so let's set this up first. We know that we're going to have some conversion factor. So some conversion factor equal to 1. And then we're going to have the inverse of that conversion factor, which will also be equal to 1. Let's do that really quickly here. So I'm setting up this, setting the stage here, and we're going to copy this 3 times because we have 3 different equalities that we can use to create conversion factors. So let's set this up here as well, and one more time. And so what are our conversion factors going to be for the first equality here? We have 1 red square equals to 3 green circles. We want to make it equal to 1. And so we know that if we divide anything by itself, it does equal to 1. And so if we take whatever's on the left side of the equal sign and divide it by whatever's on the right side of the equal sign, that's going to give us the number 1. So let's go ahead and do that here. And I'm going to just take a shortcut because I know what's coming up. And I'm going to put this over my denominator over here because by this point, we've made a couple of conversion factors. And I'm just like, let's speed up this process here. So these are both correct. These are both accurate conversion factors. Okay, 1 red square divided by 3 green circles does equal 1. It equals 1 because we set it equal to 1 here, right? We said that these things are equal. So let's do the same thing now. Let's create our conversion factor for our circle and star relationship. And I'm just realizing here, we don't have enough room. Let's make a little bit more space here. This is one beautiful thing about doing this virtually, huh? I don't have to erase all of that. Okay, so let's put our other conversion factor here. And again, I'm just going to go ahead and do both sides. On one side, I'll do it with the circle in the numerator, and in the other side, I'll do it with the circle in the denominator. And now I'm going to do our stars. So 1 green circle divided by 2 gold stars is equal to 1, and 2 gold stars divided by 1 green circle is also equal to 1. And finally, we're going to make 2 conversion factors for our star and hexagon relationship. So let's make that here. Let's get our hexagons, so 5 hexagons in this case. And let's do that one more time. And so here's where we're going to have the question or the problem that we want to solve. So now let's say that our problem that we want to solve is I want to know, let's start with one that is not too complex. Let's just say I have Hold on, let me think for 1 second before I write something really wild. Okay, let's just say I have 30, let's say I have 30 blue hexagons. And the question that I have is how many red squares does that give me? So here's my question, right? This is what I want to find out. Here's what I know. Here are the tools that I made. So I developed these tools. I know that I'm going to use conversion factors, so I wrote them out so that I know how to use them. And my question is, if I start out with 30 blue hexagons, how many red squares does that get me? So let's take this and start multiplying by 1. So the first thing I'm going to do is I'm going to put my multiplication sign here, and I'm going to say, okay, let me find a conversion factor that just lets me start getting rid of hexagons, because in our answer, we don't want any hexagons. We want them gone. And we already learned last time that in order to cancel out things, we need to have them in the numerator and denominator. And so please remember here that this is the same as this. Okay, 30 hexagons is the same thing as 30 hexagons divided by 1. And so it can be useful to leave it like that. I'm going to go ahead and leave it like that. Which conversion factor can we use to start getting rid of hexagons? So looking over here, which of these tools can we use? We're going to multiply it by 1. Which one will we multiply it by? So we definitely want one of these. If I used this one, I would end up with more hexagons in the numerator, and that's not what I want because I can't cancel it out. So let me use this conversion factor and put it over here. Now, I could go ahead and start canceling that out and then see how many stars I have and then do the next step and the next step. But here's what's really cool about dimensional analysis. You can do it all in one step. So now I know I'm going to go ahead and just do this. I'm going to cancel out my blue hexagon and my blue hexagon. So that's great. I don't have to worry about hexagons at all anymore. They're gone. So now let's see what else I can do. I don't want stars, right? The problem did not ask me about stars. And so let me use a conversion factor that lets me get rid of stars. So I need the conversion factor with stars in the denominator. So let me pull it over here. I'm going to multiply this by that. And now, once again, I have the ability to say, great, now I can cancel out 1 star in the numerator and 1 star in the denominator. But we're still not done because we still don't have what we want. The problem says how many squares, and right now the units that we have are green circles. So let's keep going. Let's multiply by 1 again. I'm sure we can find a conversion factor that gives us what we need. So we have green circles in the numerator. We need a conversion factor. We need to multiply by 1 using a conversion factor that has green circles in the denominator. So let's go ahead and do that here. This is the only option. And once again, let's just go ahead and cross out our units because that allows us to see, boom, we have exactly what we want in terms of units. We don't have any of these other units. We have the only unit that we care about, which is this red square. And so now let's rewrite what we have without all these confusing units that we don't have anymore. We cancel them. They're gone. So remember that we're going to multiply everything in the numerator and then multiply everything in the denominator. So in our numerator right now, we have 30 times 1. And remember that this little dot is another way of saying times. So don't let that confuse you. There are so many different ways to write things in math. Get used to being flexible with how you see things. So 30 times 1, that's right here. 30 times 1, and we're going to do times 1 times 1. 30 times 1 times 1 times 1, all divided by 1 times 5 times 2 times 3. So 1 times 5 times 2 times 3. And our numerator is super easy. We can multiply 30 by 1 as a million times and we'd still just get 30. So we can just leave 30 there. And in the denominator, 1 times 5 is just 5. 5 times 2 is 10. And that's in 10 times 3 is 30. And isn't this satisfying? We now have 30 divided by 30. We can cancel out both 30s, just like we've been canceling out things all this time. And that equals to 1. So we have said that, oops, I made a big mistake there. Hold on a second, because that doesn't make any sense. I forgot that we still had our square over here. And so our answer is 30 blue hexagons is equal to 1 square. If you ever see a number without a unit on it in chemistry, you should get really concerned. That should be a big red flag, because in chemistry, we always, always, always have units. Okay? So hopefully this problem has shown you the power of dimensional analysis and using conversion factors. As you get better and better at this, you will get faster and faster. For now, the expectation is when you show your work in an assessment, you need to show the conversion factors that you've used by setting them equal to 1. And then you need to show units every single step along the way. That is really, really important. Even when you're working in your own notebook and writing your own notes, get into the habit of that, because otherwise it can be really challenging to keep track of your units. Good luck.